Hello, I'm Jenny Lynch, and this is the Creative Science for Kids podcast.
Hi, I'm Matilda, and today's show is all about the science of magnets.
It's time to get drawn in with fascinating fast facts about magnets, a deep dive into what makes a magnet, a question about how animals use magnetic fields to navigate, some ideas about the many uses for magnets, and a very attractive experiment for you to try yourself at home. It's time to feel a force of attraction because here come 5 fun and fascinating fast facts about the science of magnetism.
Fact number 1. A magnet has a north pole and a south pole.
A magnet is surrounded by a magnetic field. If the north pole of one magnet is close to the south pole of another magnet, there will be a force of attraction pulling the two magnets together.
Fact number 2. Opposite poles attract, but like poles repel.
If the north pole of one magnet is close to the north pole of another magnet, there will be a force pushing the magnets away from each other. In other words, the magnets repel. The same thing happens if two south poles are close together. They repel, which means there is a force pushing them away from each other.
Fact number 3. The Earth is a giant magnet with a north pole and a south pole.
The Earth is surrounded by a magnetic field, just like smaller magnets are surrounded by magnetic fields. We can't see the Earth's magnetic field, but we can detect it using a compass.
Fact number 4. A compass can be used to find the direction north. It has a small magnet inside it that points towards the North Pole.
The north pole of a magnet was originally called the north-seeking pole because it points towards the Earth's north pole. The north pole of a magnet is really the opposite pole to the Earth's north pole, but we say north pole because it's easier to say than north-seeking pole.
Fact number 5. The Earth has 2 north poles, the magnetic North Pole and the geographic North Pole, which is also called true north.
True north is a fixed point on the Earth, but the magnetic North Pole moves around a bit. The needle of a compass points towards the magnetic North Pole, and for a long time people have known that the direction of the needle changes slowly over time because the position of the Earth's magnetic field changes.
Let's take a deep dive into what makes a magnet magnetic, and why some metals are attracted to magnets and others are not.
When you hear the word magnet, what does it make you think of? Maybe you have magnets on your fridge to hold notes and other pieces of paper. The door of your fridge probably has a magnet to keep it closed too. There are magnets in some toys, like toy trains with magnets to connect the carriages, and construction toys with magnets to hold the pieces together. Magnets can be made out of metal, but not all metals are magnetic. Iron is a type of metal that can become magnetic, and iron is one of the few metals that can be attracted by a magnet. These metals are called ferromagnetic, and other ferromagnetic metals are cobalt and nickel. Most everyday objects that are ferromagnetic contain a lot of iron. For example, steel is used in a lot of everyday items like cars and fridges, and steel is made from iron. When you stick a magnet to a fridge door, the magnet is attracted to the iron in the steel door. Metals that are not ferromagnetic include copper and aluminium, and these metals will not stick to a magnet. If you hold a magnet close to an Australian coin, for example, the coin will not stick to the magnet. That's because Australian coins are made mostly of copper, and copper is not ferromagnetic.
Now it's time for a question. How do animals use the Earth's magnetic field to find their way around?
Humans can't detect the Earth's magnetic field unless we have the help of a compass or some other device. But some animals have magnetoreception, which means they can sense the magnetic field surrounding the Earth. Homing pigeons can sense small changes in magnetic field strength to find their way home. Pigeons have tiny pieces of a mineral called magnetite in their beaks, and it's thought they might be able to sense the Earth's magnetic field because the iron in the magnetite lines up with the Earth's magnetic field lines. Pigeons also have specialized cells in their eyes that might allow them to see magnetic field lines, making the invisible lines visible, but scientists are still not 100% sure how they do it. Another animal that's excellent at finding its way around is the green sea turtle. If a female green sea turtle is born on a particular beach, she will live most of her life a very long way away from the beach, but she'll return to the same beach to lay her eggs. She might travel for thousands of kilometres to find the best place to eat before swimming back to the beach to lay her eggs. Scientists know that baby sea turtles and adult sea turtles use the Earth's magnetic field to navigate huge distances across the ocean. But, like with the magnetoreception in pigeons, there is still a lot to learn about exactly how they do it.
Magnets are very useful things, and humans have been making use of their attractive properties for hundreds or even thousands of years.
Lodestone is a naturally occurring magnet that will attract iron metal. It's made from magnetite, which contains iron, and ancient people discovered its attractive properties. These days, magnets are used in lots of technology, including electric motors, headphones and speakers, and computer hard drives. Magnets can be found in cars, microwave ovens, and latches to keep cupboard doors closed. In recycling centres, magnets are used to sort different types of metal. To pick up metal and sort it into different piles, recycling centres use electromagnets. An electromagnet is a magnet that can be switched on and off. It's made from wire that's wrapped around a piece of ferromagnetic material. When an electrical current passes through the wire, the ferromagnetic material becomes magnetised and it acts like a magnet, so it can pick up ferromagnetic objects. When the electrical current is switched off, it stops being a magnet and drops the objects.
Magnets are also very useful for looking inside the human body.
X-ray images are great for looking at bones, but magnetic resonance imaging, or MRI, allows doctors to have a detailed look at soft tissue inside the body, including the brain. The patient lies in a tunnel inside a very strong magnet. Radio waves are switched on and off very quickly, and detectors pick up signals from atoms inside the patient's body. Powerful computers then process the signals to create detailed images. A ferromagnetic substance can be magnetised and turned into a magnet.
You can test this out yourself. Make sure you tell an adult what you are doing and ask for their permission first. You'll need a magnet and 2 paper clips.
Start by straightening out one of the paper clips so you have a long piece of wire. Hold one end of the wire in your hand. Use the other hand to rub one end of the magnet along the free end of the wire. Only rub in one direction, lifting the magnet off the wire when it reaches the end, and rub the magnet along the wire 20 or 30 times. Put the magnet to one side and hold the free end of the wire close to the other paper clip. The paper clip should be attracted to the magnetised end of the wire. If it doesn't work, try rubbing the magnet along the wire again. Paper clips contain iron, and the iron atoms are in groups called domains, which are like tiny magnets with north and south poles. Before the wire is magnetised, the domains are pointing in all different directions, and the magnetic fields cancel each other out. Rubbing the magnet on the wire causes the domains to line up so they are pointing in the same direction. The magnetic fields of the domains add together, and the magnetised wire is surrounded by a magnetic field which attracts the paperclip. People often ask what first attracted me to science, and now you know. Thanks for listening, and remember to stay curious.
The Creative Science Podcast was recorded on the traditional lands of the Bidjigal people. For more information about Creative Science Australia, visit creativescience.com.au.